Hi there, here's a new puzzle. This is called the Hourglass, or maybe it's called Anti-Springer Killer. I don't really know which one of these is the title. Anyway, this is by Glum Hippo, who recommended this puzzle on the Discord server. Um, it's normal Sudoku plus cages, so killer Sudoku, plus anti-knight. So I'll show what that means in a second. And I think it's quite a nice puzzle. So this is what it looks like. Anti-knight means, let's take a look at the nines. It means any cell a knight's move away cannot be identical numbers. So this nine means these can't be nines. This nine means these can't be nines. And let's just start by eliminating everything that we can using that basic forms of that. Okay. So we've got anti-knight and we've got killer cages. Let's move me over here. Now, first thing we can do is look at this, start looking at these cages. This 30 cage cannot contain a 7 because the 7's here. So let's see, can we exclude a 6? If we exclude a 6, the biggest we can have is 9 and 8, and we don't have 7 and we wouldn't have 6, so we would have 5 and 4 and 3. That only gets to 29. So this must have a 6 in it. And since it can't miss a 6, it obviously can't miss an 8 or a 9. So this, I'm actually just going to update this label to note to myself, this must have a 9, an 8, and a 6 in it. Now further, well actually, so this means these guys can't be 9, 8, or 6. Now can this have a 1? The largest sum we can have, if we have 9 and 8, we can't have 7, but if we have 6 and 5 and a 1, we only get to 29. So this guy cannot contain a 1. Let's look at this guy and let's see what happens if this doesn't have an 8 in it. If there's no 8, we could have 9 plus 7 plus 6 plus 5 plus 4, which only gets to 31. So there must be an 8 in this, and there must also be a 9 in this. So I'm gonna, again, I'm just gonna mark that, 9, 8. But can it have a 1? If we have 9 and 8 and 7 and 6 and 1, we only get 31. So this guy cannot have a 1 in it. So we've eliminated 1 from both of these. And what does that mean? It means the 1 in box 2 can only be here. So this 25 cage, the 1 certainly can't be here, but it must have a 1 in it. So let's think about the sums of this 25. Now this 9 here has done something interesting. This 9 can, by normal Sudoku rule, see all of this, but through anti-knight can see this and this. So this 9 has eliminated 9 from all of here. So what sums can we do? We must have a 1. We can't have a 9. What happens if we don't have a 7? We would have 8 and 6 and 5 and 4, and we wouldn't get where we need to go. So we can't lose a 7, and which means we can't lose an 8. So this must contain 8 and 7 and also 1. So there's only 2 more in here that we don't know yet. There's 8, 7, 1 and then 2 more. Now let's think more about 8s. This here must contain an 8. This here must contain an 8. So in these 2 boxes, box 1 and box 2, there are 2 8s, and also in these 2 cages there are 2 8s. What that tells us is the 8s have to be in these two, that the 8s can't be in these 2 boxes outside of these 2 cages, which means we can remove 8 from all of these options. And what do you know? This 25 needs to have an 8 in it. The 8 can only be here. So we've placed an 8 here. Now I'm going to try to be good here and remember always to do anti-knight eliminations whenever I place a cell. So that's pretty cool. Now this 8 already gives us some really interesting things. I'll look first at what it does in boxes 1 and 2. Boxes 1 and 2, since they contain 1 to 9 twice, must sum to 45 each, so must sum to 90. But we know that all of this stuff here sums to 25 plus 30 plus 32. So what we know, we can know something about the sum of these four. And what it is, it's going to be, we're going to take this 90 plus this 8. So we're going to say we have 98. We're going to subtract 30. We're going to subtract 32, and I'm going to subtract 25, and we get 11. So we know that these guys here add to exactly 11. Now I could add another cage, but I'll to keep this hourglass beautiful, I'm going to leave it. But okay, 11 in four different cells. Well, the minimum with four cells is 1, 2, 3, 4, which is 10. So this must be 1, 2, 3, 5. Interestingly, because that's the only way we can add to 11 in four cells. Now, since these must be 1, 2, 3, 5, these guys cannot be 1, 2, 3, or 5. Now, that's probably going to give us more, but let's take a look here at this box, box 5. We know the sum of the whole box is 45. We know this is 30, and this is 8. So the sum of these three must be 45 minus 30 minus 8, which is 7. So the only way to add to 7 in 3 cells is 1, 2, and 4. So we have a little 1, 2, 4 triple here, and we can remove 1, 2, 4 from this. And now I'm going to mark this cage as complete. I know that the 5 values in this cage are 3, 5, 6, 7, 9. So I'm going to say this is 30 star, and that just is a note to myself that I've completed it. Let's take a quick look at the ones, because I noticed that we can't have a 1 here, which is because of this and a knight's move. The 1 must be here and here, which means it cannot be over here. Also, the ones up here eliminate these two. These two cells can both be visible via knight's move from here. So the 1 has to be one of these two, and we can do that. Now, the 30, the only way to add to 30 in 5 without a 9 is 8, 7, 6, 5, 4. 8 plus 7 plus 6 plus 5 plus 4 is 30. So the values here are 8, 7, 6, 5, 4. And I'm going to again mark that that's complete. And we've eliminated 1 here. So now we know that in this column, the only place for a 1 is here. So I'm going to place a 1 here, remove it from here, and we'll probably do some more with that, but not right now. For now, we're going to think about the fact that we removed 1, 2, 3, 5 from all of this. And there's one value I can see in particular that must be here, and that's the 7. So the 7 in box 1 must be in one of these three, which means it cannot be here. And we also knew that a different way, because we knew that this had to have a 7 in it, and it couldn't be here. So one of these was 7, and that removes those 7s. Anyway, we know that the 32 must have a 7 in it. So I'm going to mark that and say it also contains a 7, but that tells us a little bit more. 9 and 8 and 7 is 24, which means the last two digits must add to 8. Now, if I put a 4 in, then the other one would also need to be a 4. But we can't have two 4s in this cage. So I'm going to say there can be no 4 in this cage. And now that means the 4 in box 1 must be one of these two, and we can remove these 4s entirely. And also we know that there's a, well, actually now we know all of the values here. We know there's a 9 and 8 and a 6 and a 4. 9 plus 8 plus 6 plus 4 is 27. So they must also have a 3 in it. So I'm going to say, I'm going to set this to 9, 8, 6, 4, 3. And I'm going to say, make a note that that is a decided cage. What was the other thing I was going to do? This is 4. This is 7. Oh yeah, and now we know that there's a 4 in here. So we know 9, we know 8 plus 7 plus 1 plus 4, that gets us to 20. So the other one must be 5. So this guy, this must be 8, 7, 1, 4, 5. And I'm going to mark that 25 cage as complete. Okay, now this is decided, and now where can the 2 be here? The 2 must be in one of these two. So now we know the 32 must have, it must have 9 plus 8 plus 7 and a 2. So it must also have a 6. So it must be 98762, and it is decided. So now we know the value of all of this. So that's pretty cool. We were able to completely deduce the candidates that make up the digits that make up these cages. So the next thing I'm going to do, we've done most of this stuff up the top. We can't do much here, but let's look at this column. This is kind of the column where the hourglass is dropping. I'm going to look at the value 2, and I can see the value 2 can only be here or here. Now, this actually can't be a 2 because in box 5, the 2 must be here or here or here, but this guy can see these two guys from anti-knight and this because it's in the same cage. Now for those same reasons this can't be a 4, so this guy cannot be a 2 and cannot be a 4. What does that mean? A 2 in this column has to be here. Now let's think about the 4s. The 4 can be here or here, but now let's take a quick look at this 16 sum. Out of 5 different digits, the smallest we can get is 15, 1, 2, 3, 4, 5. So 16 has to necessarily be 1, 2, 3, 4, and 6. So I'm just going to note that that 16 is complete there. And now we can do some anti-knight stuff. No, not even anti-knight. We can do stuff with these two. These two cells can see all of these cells. And since we must have 1, 2, 3, 4, 6 in all of these cells cannot be 1, 2, 3, 4, 6. Now let's take another look at our magical center column, and 4 can only be placed up here. Now from anti-knight, we can remove this guy and this guy. We also remove U and U, and that places a 4 here. Now anti-knight is going to kill that, and that, and that. Now in this column, one of these must be a 4, so this cannot be a 4. We must have a 4 in this 30 cage, so these guys cannot be 4. We must have a 4 in column 1, so these cannot be 4. Let me think. All right, one of these must be 4. Therefore, but neither of these can, because each of these can see both of those through direct and anti-knight. So these are not 4. One of these must be that's not. So that is. Now, what else? Since one of these must be, neither of these can. Um, Interesting. Oh, look, in this row, one of these must be, so these cannot be. Aha, if this was a 4, it would be able to see this and this and this, and it would totally ruin this box of 4s. So that can't be 4, and for the same reason, that can't be 4. Now, in this column, we must place the 4 here. Interesting. Now, I believe there's something interesting we can do up here. Yes, in this box, we have a 3698, a 3689 must be in one of these 4. It's like a naked quad. But this cell here can see all of them, which means this cannot be 3, 6, 8, or 9, and therefore it must be a 4. Which means this must be a 4, and this must be a 4. The next thing I'm going to do is look at 6s. So the 6 in this 30 cage must be one of these two. So I can eliminate these 6s and eliminate everything up here. And now these 3 eliminate these down here. Now since one of these must be a 6, and this cell is visible by knights to both of these, that can't be a 6, which means one of these must be a 6. I can kill these and kill that. That's a 6, that's not a 6, that is a 6. And from anti-knight, this 6 removes him. So that's pretty cool. The next thing I'm going to do is look at the final cage at the top that I haven't got sorted out. This is the 22. Now the 22 doesn't have a 9 in it or a 7 in it. It does have a 4. Now, what if it doesn't have an 8? If there's no 8, then the max it can be is 6 plus 5 plus 4 plus 3 plus 2, which is only 20. So there must be an 8 in here. So the 8 can't be here, and the 8 must be placed here exactly. Now, what else? We know in this box that this is 22 and 9 and 7. So if I take 45 and I subtract 22 and 9 and 7, I get 7. So these must sum to exactly 7. Now, since there's a 4 here, there can't be a 4 here. There also can't be a 3 here. Now, these 3's up here eliminate that 3 and these two 3's. So there must be a 3 here. I can remove that 3 and I can remove that 3 by anti-night. Now, this 22, we have 8 plus 3 plus 4. Now, we need another 7. And we can't do that with a 1. We're going to have to do that with a 5, 2, which means this is now a 1, 6. Now, this 1, 6 kills 1, 6 from down here. And we have a hidden 1 here. And also we have a hidden 1 here. That gives us a 5 here and eliminates that from anti-night. And what's next is me forgetting to do anti-night stuff. This 2 here eliminates that 2. So we now have a 5 here, which eliminates this 5. Gives us a 5 here, eliminating these 2. We have a 2 up here. Now, this 1, 2 pair here eliminates 2 from all of these. We now have a naked 1, 7 here. A 1 naked pair. So I can remove 1, 7 all the way down here, and we have a 2 placed there. Anti-night kills that. We now have a 1 placed here. All right, now the 2 in row 9 must be one of these two, so we can eliminate these. The 9 in row 8 must be one of these two, so we can eliminate these. Now let's get a bit sneaky with 6s. 6s must be one of these two, so cannot be either of these two for anti-night reasons. And now naked 4, 7. So I can remove 4, 7 from these. They're not 4, 7. And we have a 9 here. So 9 can go here, which means 9 is not there. And because of this cage, 9 is not here. So we can place a 9 here and then eliminate these two from being 9. Now in this row, the 9's got to be there. That's all pretty good. What else? Look, the 9's up here. Eliminate that, so that's a 9, which eliminates that, so that's a 9. Okay, cool. All the 9's done except for these two. Now, I think placing the 9 in this 24 is important because that's a big number and 24 is not that big. So we've got a 4 and a 9. The smallest other two we can get is 2 and 3. Now, if we add a 7 as well, we've got too far. Now, that means that these guys cannot be 7 or 8. Now, I think both of them are going to be, yeah, both of them are useful because now these two must be 7 and 8. In this box, these are the only things that can be 7, 8. They must be 7, 8 exactly, and these cannot be 7, 8. So a 5 is here, and now this 24 is 4 and a 9, and we have this 2 and a 3. So we're going to have 4 and 9 and 2 and 3, and how much do we need to get there is 6, I think, yes. So we can place a 6 here. That puts a 6 here. What else? Oh, yeah, 3 here, easy. That's not a 3. 3's got to be there. 2's got to be here, which anti-night. 2's got to be here. 3's got to be here, anti-night. 2's got to be here. Can't be there, so 2 must be there. 3's got to be there and there. Now, anti-night, since one of these must be 3. These can't be 3, so we've got to place a 3 there and there. We can put an 8 there and then there and here. We've got some 6s, some easy 6s. We've got a 1, a 1. We've got a 7. Takes out that 7. We've got a 7 here. We've got a 7 here, so there, so there. Since one of these must be a 7, these two can't be, so that must be, which makes that a 7, and that a 7. 4 here, 4 here, 5 here, 5 here, naked 5 here, 8's here, there. I think this puzzle might be finished. Here's this last section I did just before without the microphone on, so I had to do it again. Check errors, everything is good. It checked anti-knight and basic. I will update my solver to check caged sums. But there you go. That was quite a fun puzzle. I liked how much proper anti-knight was in this. I like tricky anti-knight logic. So thanks very much, Glum Hippo. I recommend this puzzle. Yeah, I'll see you on the next one.